a Portland Community College mathematics telecourse, a course in arithmetic review, produced at Portland Community College. This short lesson concerns ourselves with the subtraction of two fractions, which is essentially the same as addition. That is, to subtract two fractions, you build each to have common denominators, subtract the numerators, and write that difference over the common denominator. Then, reduce if possible. First, the common denominator. What's the lowest number that each of these two will divide into? And it appears to be 24. Then we build each of these to be 24. So by multiplying 8 by 3, I would get 24. But then I must multiply the top also by 3. Then multiplying the bottom of this one by 2 to get 24, I must multiply the top also by 2. So that this top has in effect become 21 and this top 10. So now I have 21 subtract 10, which is 11 over 24. Then we ask, can it be reduced? In this case, no. Then we're done. Just that simple. Get common denominator. Build each to have the common denominator. Subtract the tops. Gives you the top of the answer. Then reduce if possible. That's really all there is to it. And rather than stopping there, though, let's use this as an opportunity to review finding the lowest common denominator of very messy fractions. Are you beginning to get comfortable with large denominators? Can you see what we're asking for is what's the least common multiple of these two numbers? For sure it'll have to be larger than 525, perhaps very large. We're asking what's the lowest number that both of these will divide into. Our first rule, we recall, was to prime factor the denominators and write in exponent form. So let's concentrate here. Prime factor that and write in exponent form, and we get this. 495 is 3 times 3 times 5 times 11, which in exponent form is 3 to the second power, 5 to the first times 11 to the first. Now let's do the same thing to that denominator, and we get this, which we write as 3 times 5 squared times 7. Now, of course, naturally, this division takes a little bit of time, but not that much. Now, to get the least common multiple of these two denominators, which have been rewritten in prime factored form, we list all the different bases as factors to be. So we need the base 3, we need the base 5, the base 7, and the base 11, writing them in sequential order to keep our thinking more orderly. And then give to each base the highest exponent used up here. So on 3, the highest exponent is 2. On 5, the highest exponent is 2. On 7, the highest exponent is 1. On 11, the highest exponent is 1. And that number is the lowest common denominator. And furthermore, from this factored form, it's easy to find the appropriate fraction building numbers. Let's see how that works. We want this one to look like this one, but this one has 2 3s, so does this. This one has 2 5s, this one has only 1, so I'll need one more 5. This one has 1 7, this one has none, so I give it one more. This one has 11, this already has it. So I needed the additional factor 35 on the bottom to make this become this. But then I must multiply the top by 35 too. Now the same thing here. I want this to look like this. I need 2 3s. I've got 1, so I need one more 3. I need 2 5s. I've got them. I need a 7. I've got it. I need an 11. I don't have it, so I give it to myself. So in this case, I've had to multiply the bottom by additional 33 to make it become this. So therefore, I must multiply the top by 33 as well. So now, multiplying 35 times 71 in this case, the new transformed top becomes 2485. And multiplying these two factors, that top becomes 264. And now subtracting this top from this top to get the top of the answer, we get 2,221 over the product of these four factors. Now let's concentrate on the matter of reducing. By leaving it in prime factored form, we can see clearly that the only prime numbers that will divide the denominator is 3, 5, 7, and 11. Hence, they are the only candidates to try to reduce the top. So checking 3, we add the digits on the top, which gives us 7. 3 will not divide into 7, so it won't divide into that. 5 will not divide into that because the units digit is not 0 or 5. Now there is a divisibility test for 7, which we didn't give you. It's somewhat messier. The easiest divisibility test for 7 for us is to actually try to divide the top by 7. To save time here, we'll use a calculator. So 2221 divided by 7 is, and we can see we get a decimal point, which is the same thing as saying it doesn't go in here evenly. The same with 11. We'll take the 2221, try to divide it by 11. Again, we get decimal. So since none of these will divide into this, that tells us it's already reduced, which means that all that's left for us to do now is to divide out the bottom. Well, in this case, since we have a calculator, we'll continue with it. 2 3s, or 3 times 3 is 9, times 2 5s, or 5 times 5 is times 25, times 7 times 11 is 77, is 17,325. So 2,221 is a numerator, 17,325 is the denominator. Messy, but rather routine. It should give you a sense of power, because most people would hesitate to do a problem like this. But if you've been following these lessons carefully, indeed, now you can. As messy as the arithmetic of finding least common multiples was on the last problem, you should realize that the principle involved is exactly the same as for this simple problem. That is, to subtract two fractions, we ask first, are the denominators the same? And if they are not, we can't subtract until they are. So then we ask, what's the lowest number both 9 and 15 in this case will divide into? And if you just see it, and in this case it is 45, you're in business. But if you don't just see it, then you forget this problem and go to a side problem of listing your denominators. Then you go through the procedure we've already established and reviewed so many times of finding the least common multiple. But in this case, we can see that to build 9 into 45 by the multiplication procedure, I need a 5 as a factor, top and bottom, and that not only causes the bottom to become 45, the top has now become 25. Same fraction, just written differently. And we can see that to build 15 into 45, I need the factor 3 on the bottom and on the top. And so the top now becomes 12. Now we simply do the subtraction of the numerators because the bottoms being the same gives me permission to add or, in this case, subtract the numerators. So 25 subtract 12, we can just see is 13. Then, of course, see if the problem is reducible. Easy? So was the last one. Just messier arithmetic, whole number arithmetic, involved in finding the least common multiple. Now, sometimes finding the common denominator isn't as obvious as this, but at the same time not as messy as on the last problem. Say with this problem, it's not quite so obvious what the lowest number is that 35 and 49 will each divide into. Even though these are too involved to see the lowest common denominator, at the same time they're too simple to go to a separate sheet of paper and begin to prime factor, because we can just see that that is 5 times 7, and that this is 7 times 7, and we will build our common denominator right over to the answer where it's to be. So we can see I need a 5, but I need not a 7. In fact, I need 2 7s, and I might just well write it for what it is. It's 49. So I know that 5 times 49 is going to be my lowest common denominator. But I need not multiply this out. As it stands, I want this to be like this. Well, I know the only difference is this has one less 7 than this. So this tells me to multiply top and bottom by 7. Now this is the same as this, and the new numerator becomes 63. Okay, now I want this also to be the same as this, and I can just see that all I need is the additional factor 5. So now this 2 is the same as this, and the new numerator becomes 25. So I subtract 25 from 63, doing it vertically if you need to, but try more and more to do much of your arithmetic mentally. So 5 from 13 is 8. We borrowed 1 from there, so 2 from 5 is 3. Now, the only numbers that's going to divide the bottom is 5 and 7, and we can see that neither 5 and 7 will divide this, so we know it's in reduced form. Frequently, it's easier to reduce if you leave the bottom temporarily in factored form, because it's easier to see its divisors then, hence to try them on the top. Then, as in this case, if there are no common divisors, then you multiply the bottom factors. So 5 times 9 is 45, carry the 4. 5 4s is 20, and 4 is 245. It's rather interesting when you think about it. We can't subtract until I have common denominators, which implies I need to know what that is before I even start. But in fact, we didn't know, place value-wise, what my denominator was until I was all done. So it's not knowing what the denominators are, it's knowing that they're the same that allows me to work. Do you see the point? It's a very important one. But please also note that most problems you will encounter are simple enough that you'll either see the lowest common denominator, or with a quick factorization you can determine it right on the spot. This is an appropriate place to sort of look ahead. That is to the time when we'll get multiple operations being done. That is, order of operations. We know that if there's nothing but additions and subtractions, we do them as we come to them. So this in effect says, do this subtraction, get an answer. Add that answer to 5, 6, get another answer, subtract from that 1/4. However, we know that there is a common rule for both adding and subtracting. And that is, I can't do either unless the denominators are the same. And very often, it's just as convenient to get that common denominator all at once, if you're only adding and subtracting. If we were to throw a multiplication and division in there, then that will complicate the matter, and we'll discuss that in a couple of lessons. But if there's only additions and subtractions, it's often very convenient to find that common denominator, which will be the denominator of the final answer of all of the operations, to find it all at once right off the start. So we look at each denominator and ask what's the lowest number each of them will divide into. And in this case, we can easily see it's 24. Then we build each one to make their denominators become 24. So we can see with 8, I need a 3. With a 12, I need a 2. With a 6, I need a 4. And with a 4, I needed a 6. And of course, whatever I multiply the bottoms by to make them become that lowest common denominator, I must multiply the tops of the fraction by the same amount. So now I've in effect changed the forms of all the fractions. The bottoms are all 24, and the tops have become now in these cases 21, 10, 20, and 6. Now that the denominators are all the same, I have permission to subtract and add and subtract again the tops. So doing it in the order that I come to them. Now recall, in the order of operations, when I have nothing but subtractions and additions, I do them as I come to them, reading from left to right. So 21 minus 10 is 11. 11 plus 21 is 31. 31 subtract 6 is 25. Then in this case, we can see that I can divide 24 into 25 just once, with a remainder of 1 over 24. So I'm done. So observe this in the future. Very frequently, particularly in formulas that you encounter in science and business courses, you will get multiple operations. So remember, if it's nothing but additions and subtractions, in a sense, you can do them all at once, being sure that you do them as you come to the operation signs rather than jumping around, and being sure first that because you're adding and subtracting, the denominators must be the same in order to add or subtract. Let's spend a few moments looking at some word situations involving subtraction, because after all, most problems in science and business will not be given to you all written out like we do in our exercises. They'll be given to you in words and usually spoken. If we have the phrase subtract 3/8 from 5/6, it's fairly clear to most people that what we're asking here is 5/6 subtract 3/8. It doesn't confuse us that 3/8 is written first in the word statement and written second in the math statement, because it's saying subtract from. So here I have to subtract from the number in front. Okay, let's go ahead and work this very quickly. You can see that the lowest common denominator is 24, which will be the denominator of my answer. I need to multiply top and bottom here by 4, getting a new numerator of 20. I need to multiply top and bottom here by 3, getting a new numerator of 9. 9 subtracted from 20 is 11, and I'm done. So note, the number following the subtraction is the one that's being subtracted. The number in front is the one it's being subtracted from. Most people are well aware of this in this particular verbalization. However, observe this next statement. This kind of verbalism, on the other hand, is not so common to the beginner. That is, what number is 1/5 less than 3/4? There is a tendency on some people's part to want to say 1/5 minus 3/4 because they think the word less means subtract. But what we're dealing here is not the word less, but less than. And you simply have to learn as a language fact to be told and remembered that less than used in this form means that the first number, as with the last problem, will be written second, and the second number will be written first, because this says I'm going to take 3/4 and subtract 1/5, which means I will get a number that will be this much less than this, and that's what we're asking for. So, just remember, when you see a statement, what number is something less than something else, the first number stated in the sentence is the one being subtracted. And the second number is the number being subtracted from. Now, of course, we can just see that the common denominator is 20, so I need a 5 factor here and a 4 factor here, and we have 15 minus 4 is 11, and I'm done. That's fast and easy, isn't it? Let me spend a few moments and share with you a nice shortcut which makes easy problems even easier and faster. Take the problem we just got done doing where the answer was 11/20. Look at this down diagonal and multiply those two, and you can see that that's 15. I'll write it down here, but the trick to this shortcut is not to write it down, but to remember it. Then subtract the product on the up diagonal, which is 4 times 1. And of course, that's going to give me 11. Then put that over the product of the bottom, which is 20. And there I'm done. If it looks a little bit complicated, it's because it's new and because I'm using words. Actually, if you just watch and see the pattern, this gives you a remarkable shortcut which will allow you to do certain problems, simple ones, mentally. So let's look at that pattern without looking at specific numbers, and let's show that it also works for addition. If you take the product on the down diagonal, the product of these two, by the way, whatever they are, that's going to be held in my mind first. Then I'm going to add the product on the up diagonal. And then I write it over the product across. So think down diagonal plus or minus up diagonal over across. And it's just that simple. Now, if you're good at mental arithmetic, follow me. The down diagonal is 21. The up diagonal is 16. 21 subtract 16 is 5. Then the across diagonal is 24. So there, my answer is 5/24. little bit of practice, you'd be surprised how fast this is, particularly with simple problems like this. The down diagonal is 12, subtract 5 is 7 over 20. See how fast that is? With a little practice, you can actually work problems, simple problems, as fast as somebody writes them down. You can spew the answer right back to them. Now you can see why this works. If I were doing it by our basic technique, I would get the common denominator, which in this case is 5 times 4. Then I have to multiply top and bottom here by 4 to make this 20. So I'm going to get 3 times 4, which is what the down diagonal was anyway, wasn't it? Then I have to multiply top and bottom here by 5. So 5 times 1, which is what I get on the up diagonal anyway. So since this pattern exists within simple fractions, sometimes it's just as fast to go ahead and get the answer mentally. And of course, check to be sure that it's reduced. Can you just look at this and tell me that the answer is 11/15? See, the down diagonal is 6 plus 5 is 11 over 15. Not at all difficult, isn't it? Now if I had had a subtraction instead, the same pattern, except I subtract from the down diagonal the up diagonal. So this is going to be 6, subtract 5, that's 1 over 15. You might practice that a bit. If you find that you like it, then remember it and use it. Now the obvious shortcoming of this, by the way, technically it will always work. As in this case, the down diagonal is 20, subtract 8, which is 12, over 32. But this is quite reducible. I can divide top and bottom by 4, and that gives me 3/8. And it probably would have been just as fast to note that the common denominator here is quite obviously 8. And if I multiply top and bottom by 2, 5 minus 2 gives me 3. So in this case, this was perhaps a squidge faster. So this crisscross method always works, but always be on the alert for when you can find the common denominator quite obviously and quickly. So just several different methods. Which one to use really depends on which one you feel comfortable with in a given situation. So this is your host, Bob Fennell. Until the next lesson. Good luck.